Hi everyone, in this example we have two parts A and B, and you have to use the intermediate value theorem to prove some statements. In part A, suppose that f is continuous on the interval from 0 to 1 and that f of x greater than 0 less than 1 for all x in this interval. Use the I.V.T. to prove that there is at least one number c in the interval 0, 1 such that f of c equals c. So this is what you want to prove, f of c equals c. And if you move c to the left hand side, you will get f of c minus c equals 0. So if you prove this statement, you will prove the original one. So to apply the I.V.T., first you have to create a function. Let's say g of x equals f of x minus x. From the statements you want to prove, we replace c by x, and also you have to create an interval, and the interval is given for you in this question, and it will be from 0 to 1. Now you have to check the conditions of the I.V.T., and the first condition is the continuity. As you see, g of x equals f of x minus x. From the question, f of x is continuous on the interval from 0 to 1, and x is a polynomial, which means it will be continuous at any interval in the question. So we have f of x minus x, which is difference between two continuous functions, and that means that g of x continuous on the given interval from 0 to 1. So the first condition is satisfied. Now you have to go to the next condition, and the next condition you have to check the image of endpoints under the function g. So g of 0, these are the endpoints 0 and 1, and we will start with 0. So g of 0, from the definition of g, it will be f of 0 minus 0, and this gives us f of 0. Now you have to check what is the sign of f of 0. From the question, we have this statement that tells us f of x is greater than 0 less than 1. So f of 0 is greater than 0 and less than 1. Greater than 0 means it will be positive. So f of 0 is greater than 0, which means it is positive. Now you have to check the second endpoint, g of 1, and this is equal to f of 1 minus 1, because you have to replace x by 1. So as you know that f of x in general between 0 and 1, so f of 1 is greater than 0 less than 1, and if you subtract 1 from all sides, you will get that f of 1 minus 1 less than 0 and greater than negative 1. And f of 1 minus 1 is g of 1 as a definition of g. So g of 1 is less than 0, which means it will be negative. So g of 1 is negative. As you see, g of 0 and g of 1 have opposite signs. One is positive and the other is negative. So the two conditions satisfied for the given question, which means there is at least one c in 0, 1 such that g of c equals 0. But by the definition of g of x, g of c is f of c minus c equals 0, and if you move negative c to the right hand side, you will get f of c equal c, which we want to prove. You have to prove that f of c equals. So this is the end of part A. Now in part B, we have a function f, and the function is continuous on the closed interval from 0 to 2, and we have two statements says that f of 0 is less than 0 and f of 2 greater than 4, and you have to use I.V.T. to prove that f of c equals c squared for some c in the open interval from 0 to 2. Now, so as in part A, you have to create a function from what you want to prove. So if you move c squared to the left hand side, you will get that f of c minus c squared equal to 0. So the function is g of x equals f of x minus x squared, and the interval is given, and it's from 0 to 2. Now you have to check the conditions of I.V.T., and the first condition is the continuity. Now since g of x equals f of x minus x squared, and f of x is continuous from the quotient, and x squared is a polynomial, which means it's continuous everywhere, and since g of x is difference between two continuous functions, this means g is continuous on the closed interval from 0 to 2. So the first condition satisfied for the function g. Now the second condition is you have to check what is g of the endpoints, g of 0, and what is g of 2. Now g of 0 is f of 0 minus 0 squared, and 0 squared is 0, so we have f of 0. As mentioned in the question, f of 0 is less than 0, which means that g of 0 is negative. Now g of 2, as a definition of g of x, is f of 2 minus 2 squared, which means f of 2 minus 4. Now from the question, f of 2 is greater than 4, and you have to check f of 2 minus 4, so you have to subtract 4 from both sides. Minus 4 minus 4, this gives us that f of 2 minus 4 is greater than 0. So this statement is greater than 0, which means it is positive. So g of 0 and g of 2 have opposite signs, which means the second condition satisfied for the given function g, and this leads to the conclusion that there is c in closed interval or open interval from 0 to 2 such that g of c equals 0. But this is the definition of g of x, so g of c is f of c minus c squared equal to 0, and if you move c squared to the right hand side, you will get f of c equal c squared, and that's it. Thank you.